Real-Time Metacognition. AI has generally emphasized general reasoning principles that can apply to a wide range of entities that will be external to agents, which would include things such as naive physics reasoning, where if an object has its support removed out in the world, it might be expected to fall by the agent. But supporting reasoning about entities that are internal to the agent, such as its beliefs, is also a critical aspect. And this has been recognized and leads naturally to the need to quantify over propositions and formulas. Traditionally, whether it's through syntactic approaches using quoted formulas as the objects of belief, or modal approaches that use modal operators for belief or knowledge, this has often been assessed in terms of avoiding paradoxes of self-reference. Here, we propose a syntactic approach via quotation, but in the context of active logic, which, as will be described, is agent-like, time-sensitive, and contradiction handling. And then the particular combination of active logic with quotation is expected to together enable some advances and avoid some of these previously troublesome issues with self-reference. So to first begin with autoepistemic metacognitive reasoning, for enabling wide-ranging metacognitive behavior, an agent, a logic-based agent in particular, should have some desired abilities, including being able to reason not only with, but also directly about beliefs from its knowledge base as the subjects of reasoning, whether these might be used or mentioned. It should be able to reason in the presence of contradictions, where it would not be the case that from a contradiction everything follows. And especially for a common sense agent, contradictory inferences should generally become common events that occur throughout the course of reasoning and not disasters that indicate a poor design in the formalism. So the agent should also be able to then detect these contradictions, knowing where this lies, such as between a particular formula and its negation, resolve the contradiction, where after it's been identified what formulas may contribute, considering assumptions involved that may no longer be believed or retained at future points in time. And then after this, recount the process that there was this contradiction at a prior point, it was known to the agent to have been resolved, and also that new beliefs, which are held at the present moment in time, resulted after the process of contradiction repair. So overall, these sorts of reasoning broadly involve evolving time and a mechanism for expressing properties of particular beliefs. So then relevant to these goals, to discuss active logic, this is an internal logic, and by this meaning to draw a contrast between active logic and other kinds of logics that might be considered external, and take a stance where the logic might often describe an external observer reasoning about the agent. Instead, active logic considers knowledge and inference from a view internal to this agent doing the process of inference, and a key part of this being how the logic models the agent's reasoning as a process that unfolds evolving in time. Therefore, active logic does not at any point believe the closure of its inference rules, and so it rather trivially avoids the problem with omniscience, and instead, active logic models reasoning as proceeding over a series of discrete time steps where there is an evolving present time point during that process. And as there is a transition from one time step to the next, inference rules will be applied just once as that transition is made. Prior beliefs may be newly derived, may be disinherited from prior time points, or older beliefs inherited, and otherwise these changes to the knowledge base made. And for an example of a particular rule, we have here a rather simple inference rule that is the clock rule for active logic, relating to how it reflects its evolving present now time point. As we go from a time step t to t+1, this will be retracted, and for the incremented time value asserted now as t+1, where active logic might use this progressing now to enable particular inferences, or we can also imagine cases where the next t might be a particular time value, like 11:30, 11:31, as it tracks time unfolding. So the means of reasoning in active logic are time situated with this evolution across time steps. And the manner in which active logic beliefs are stratified across different time steps is part of the means the logic can reason about contradictory formulas. Shown here is an inference rule for part of a mechanism to respond to contradiction. At any point t, if a formula x and its negation are simultaneously present, with the inconsistency in the knowledge base at a subsequent time step, not only will there be a derivation that contra between quote x and its negation is obtained, but also this pair of formulas will not be inherited at the moment t plus 1, and other formulas referring to them that specifically we distrust x, we distrust its negation, will be obtained, and a similar process if formulas have been derived from that pair will also be known. So then active logic has some key desiderata for useful for an agent, the importance of its internal belief, being situated in time, and recovering from inconsistency and avoiding paradox using a mechanism like shown above that we believe makes it suitable for a general common sense reasoner. Then moving from active logic to some examples that show how quotation might be used. Here we don't use the full active logic syntax, but assume still that our logic will be situated in time with a relatively general first order syntax used here, and hope to show that quotation can enable more expressive rules that specify patterns of inference, which would otherwise have required multiple different schemata and are less flexible than individual rules used here. So something like if an agent has a particular goal and the condition fulfills that goal, and this condition is known to be true, marking the goal is completed and revising that, where we might use quotation terms such as that ball 256 is to be painted blue as our goal we're pursuing, a condition that satisfies it expressed with the quotation term that the color of this ball be blue, and where the no predicate is going to be determined for a particular quoted argument formula by some positive introspection lookup of whether there exists a formula matching this in the knowledge base, and then using this to reason toward the completion of it. So again, with quotation, we're able to use general formula arguments, which might have more general operators or structure than the simple atomic formula C here, and specify a pretty general pattern of what ought to be known. And this might be broadened further for other generalized cases where unification might be done when doing the lookup, or we can otherwise match a broader class of formulas with variables instead of formulas that are ground like C here. And likewise, negative introspection, of course, to proceed similarly, but check whether we have the lack of the formula in the knowledge base instead of the specific presence for no. Finally, for another example, distinguishing between experience and quoted expressions, we can consider how we might have an agent that deals with information where some of the sources of this would not be trusted without reflecting on it first. For example, if another agent who's known to be fallible reports something via language, this might be viewed as less trustworthy than something from a sensor that has been well tested. So here, quotation aiding in a general reasoning pattern by mentioning this information without committing to truth. Contrast the simple sentence that the alarm went off versus we heard from the other agent, quote, the alarm went off. And with the latter of these, there's not a truth value of true or false assigned to this. And if there are evaluation procedures or methods of inference that can examine this and take some determination before validating it, then this gives a means of holding that separately, not committing to it, and a fairly general way to respond. So then, in conclusion, general reasoning for agents will involve the intersection of issues that are both real-time and also involving metacognition and meta-reasoning. Here I've illustrated the basic features of active logic, and having done so, the key takeaway that active logic and quotation in combination seem appropriate for addressing some of these meta-reasoning problems by virtue of the key characteristics of active logic, its situation in time, its ability to handle inconsistency, and the internal nature of that reasoning. And while this work has primarily been theoretical so far, further work to be done in the concrete reasoner implementing active logic to further test and develop these ideas. Thank you, and I'd be happy to answer any questions.
Thank you. I don't see any questions on the Slack bot, so I'll ask a question. This is very cool. I was wondering if this could ultimately support, say, fluence for belief, for degrees of belief, for instance. So the scenario I'm thinking of is, suppose you're a firefighter and you're putting out a fire, and you have this belief that, I think I've put it out, I think it's out. And over time, you're going to get more and more confident in that conclusion. So the quotation would give you the ability to reason about that belief. Is that an area you're looking at, or is that covered, or?
So active logic itself is not directly probabilistic in the ways it's been developed so far, but I think what you were saying of like the threat of over time developing confidence, in some way the prior example here of working with the quoted formula as we evaluate it could reflect a similar kind of development. So even if we don't yet have an explicit, probabilities attached to something like evaluating what we heard, could imagine that, yeah, a capability for that of the process of evaluation could be extended in the direction of more explicit probabilities as that is further developed.
Okay, great. Thank you.